you. It's really lovely to be here. How are you all handling the conference? I updated the logo for you. You're welcome, Italy. Yeah. Hope you're enjoying all of it. We're going to talk about containers. Containers. What do they know? What aren't they telling us? Do containers know stuff? We've been asking these questions for so many years. And ever since we got media queries back, roughly 2010. Thanks for the slide. And media queries are great because we get this ability to measure the space that we have. Oh, that won't go small enough. No, that only zooms out. That's the wrong way. You understand what media queries are. You saw them earlier today. And then we got responsive web design, this article by Ethan Marcotte, and it really took off, and it was the whole thing for the last decade plus. But there's a little bit of a problem where we've got different cards and things in different small spaces, and what if we want to measure those? What if we could query containers? And people started asking that right away. Let's say we've got here a sidebar, and we've got a media query there, and it's working great for our big card, but it doesn't work at all for our small one. It doesn't know what space it's in. And so right away, people were coming out with polyfills for container queries. This one was called selector queries. This is from 2011. As soon as we had media queries, people wanted container queries. And we've called them different things over the years, and they've had slightly different variations, but there's been lots of polyfills and attempts to solve this problem: selector queries, element queries, container queries. And lots of demos out there of where all they could be used. We could have this calendar that changes depending on its size, and the card changes, and lots of other components. And it's been the most requested feature every year in the State of CSS survey. Everybody wants container queries forever. And the browsers heard us asking, and they said no. Containers don't know anything. Please do not query the containers. Container queries will never be possible on the web because they could cause infinite loops. And I'm paraphrasing there, but I think I said that on stage probably a few years ago. And it wasn't wrong. That's somewhat true. But to understand why that's true, we have to go back a little farther. The first web browser and the first web page, here shown on the computer that was used for the first server, which is that Next machine, which has this fancy graphic interface, futuristic. Like, that's so cool. But most of the computers didn't have that graphic interface. And you can't make a web that's worldwide by saying it works on my machine and everyone else is an edge case. So immediately they released a second browser. This browser came after the one that had more features. And it's stripped down so that it will work on any machine. You don't even need to download it and install it. You can telnet into the CERN servers and browse the web using this line mode web browser from their servers. And you get the same web pages, but they look a little different than they're text only. And this becomes the mission statement of the web. Web for all, web on everything. How many mediums have a mission statement? Did Gutenberg put out a mission statement? We have a mission statement on the web. This is it. And everything is a lot of things. There's all these mobile devices, and the web is just getting on everything, and it's sticky and kind of gross. And this is a very different way of working than in print design, where I can jump into InDesign. I can lay out the page exactly the way I want it. All sorts of guidelines. I can tell the printer what inks to use, what paper to print on, and when I get it back, I have exactly what I designed, and then you can click on it all you want and nothing happens. It just sits there. The fact that we can have that much control over the printed page is a limitation of that medium. It just sits there. It can't do something. It can't respond to context. If somebody can't read it, there's no device that's going to read it for them. If somebody has an wait, what would the older version be? I don't know. Anyway, web design needs to adapt. We need to adapt not only to the size of the screen, but the user preferences, the device interfaces. Does it hover even? Is it touch? The new features over time, we need to adapt. We need to be able to support old browsers and new browsers. And then we've got new content, and the content is often not there when we do the design, right? Sometimes we're lucky to have the content and we design around it, but often there's new content coming all the time, and our design needs to work with new content. We don't know what that's going to look like. And so right away we get normal flow, and we don't often use a name for this because it's just the default. But normal flow, or the block formatting context, or box layout, we've got a box. It has some content in it, and it's in some other boxes. We've just got nested boxes. So the content is providing some size to our box. It says, I need this much space. Give me at least this much space. That's intrinsic sizing. And we also have some keywords that let us access these intrinsic sizes: auto, min content, max content, and fit content. And then we get sizing information from outside. So the context says, here's how much space you have. Here's the size of the viewport, or the size of your sidebar, or whatever. Or styles that we set explicitly. We can provide extrinsic sizing information. So we've got this back and forth of the extrinsic and intrinsic sizing. That means, when we edit this text, adding more content, the box gets bigger around the content, but also if we change the size of the wrapper, the text moves, the content moves inside. So we've got this back and forth, both directions. And it's a really cool feature. This is really powerful. It's something that InDesign can't do because it doesn't nest things. But it's also what makes container queries impossible. If we try to measure the box and then change what's inside of it based on that measurement, what's inside of it changes the size of the box, and that changes the measurement, and we've got the infinite loop. That's why we can't do container queries. So instead, we get Flexbox and Grid, and they're very fancy. They make it so we don't need media queries as often, because these boxes sort of, I haven't set any explicit breakpoint, but they move around depending on the space they have, because Flexbox and Grid will do that. They have auto-sizing features to fit the space. So we don't need media queries as often. And Jen Simmons calls this intrinsic web design. If you haven't seen her video, Everything You Know About Web Design Just Changed from a few years back, excellent video. Intrinsic web design is this evolution of the responsive web. We're still trying to adapt to screens, but with responsive web design, we removed all the intrinsic sizes from everything. Everything got a media query and percentages, just percentages everywhere. And now we can do better. Flexbox and Grid allow us to combine fluid and fixed sizing and have them work together in interesting ways. So we get truly two-dimensional layouts, combining fixed and fluid sizing. We get different stages of squishiness, nested contexts that expand and contract with content, and then media queries only as needed. But wait, nested contexts that expand and contract with content? That sounds a lot like we're going to have things inside of boxes that we wish we could measure, like containers that we could query. And the good news is we're not in 2020 anymore, which is lucky. We're in the future. We have traffic. And nope, really no. Autocorrect. So we live in this future where we know now that containers can be queried. Large language models don't know anything. They're not connected to reality. But containers know stuff. In fact, they know things in all of the modern browsers. All of them 2 of them within 2 weeks, and then Mozilla slightly later, but they've been available for over 6 months now in all of the browsers. And so we can go back to this demo and see, let's do this one presenting here. All right, so we have this media query. Hopefully you can see that. We can bump up the font size a bit. We have a media query. We'll change that to, say, container. And we'll take the HTML, the main, and the aside, and we'll give them a container type of inline size. And now it works. Container queries in the browser. And we can do progressive enhancement. We can check whether a browser supports containment and fall back if we need to. There's a polyfill. I don't generally recommend it unless you really, really need a polyfill. I mean, it's great. It works great. But polyfills are always going to be slower than the thing. And if you can do a fallback without it, that's better. So how did we get here? How did we go from impossible to shipping in just a couple years? What about that infinite loop that was in our way? Yeah, it's still a problem. And so there are some restrictions that apply to container queries. It's not the utopia that we might hope for. In order for queries to work, we can't change the container that we're querying. When I say it like that, it feels obvious. We can't measure something and then change it. That will change the measurement. So, and we can't change it directly or indirectly, which limits us a bit. So for size-related queries, we have to turn off that intrinsic sizing feature. We just take that out of the equation so that when we change the content based on the query, the content won't change the box. So get rid of intrinsic sizing. And we already have a tool to do this. It was developed sort of over the last 5 years or so. It has some other performance use cases, but mostly it was like, maybe if we have this feature, we'll be able to do container queries, and it worked out. But we can contain size, layout, style, paint. But there is a little bit of a problem. I mean, this is easy to solve. But OK, let's just put that back. So if we go in here and we contain, let's even just contain the size. Great. We've made that worse. So size containment would be a little bit problematic. We've got this flow of information back and forth between context and content. It's a very useful flow. And if we just stomp all over the one, and then it's all just context all the time, there is no content, no, it's not going to work for us. And this was the holdup for the last 5 years. Thank you, Amy, for this slide. So what we were trying to figure out for the last, since about 2020, there were proposals for, we have everything we need, but we really need a way to do inline-only containment, because we often set the widths of things explicitly or from context externally, and then we let the height expand and contract to the content. And if we can contain one and measure that, that will give us what we need, because I already said that without going to the slide. Most web layouts have an explicit width or inline size and an implicit height or block size. So there's still a few loops that are possible in there. This is one that held us up, and I don't want to spend too much time on it. But this box can get bigger. Whoop. That's not going to work. All right. When that box runs out of inline space, it becomes too tall to fit in its context. And so it jumps to the next space, because the width got small enough that the height got big enough that it no longer fit. And then it goes to the next space where it is now wider and shorter and would fit in the height of the first space. So technically, we have a loop here. What browser engineers realized is that that's a problem with floats, and they already fixed it. 15, 20 years ago. So the problem that was holding us up, we found, was mostly fixed. So there is a little bit of a loop, and browsers just cut it off. They just say, OK, we're not going to go back once we've moved it. We're not going to let it move back. So we got inline-only containment. We couldn't do the same with block-only containment. There's too many effects that block size has on it, or that inline size has on block size. So we were able to do one but not the other. But we did get inline-only containment. And we can only measure the axis we contain. So if we contain the size, we can measure both height and width. If we contain the inline size, we can only measure the inline axis, usually the width. So for most containers, we want to only contain the inline axis. And then we can use size containment on scrollable containers, because once we've set something to scroll, we're giving it an explicit height anyway, because it can't take its height from the content. The content is overflowing. So there are use cases where we can set up different containers. They're all scrollable containers, so we can set them with size containment and measure both axes. But in most cases, we'll only measure one axis. We also, to make container queries work, we also need to contain layout and style, which has a few other implications. But since containment is invasive, we always create containers explicitly. We aren't able to just measure anything on the page. We have to say, these are the elements that I want to measure, add the containment to them, and then we'll be able to measure them. But instead of saying contain inline size, layout, style, you don't need to memorize all that. You can just say, I want a container of the type inline size, and it will apply the containment that's needed. And the containment that's needed, size, layout, and let's go into that. So we can see we've got a couple boxes here. You've already seen what happens if we contain the size. It collapses. So that's not great. Oh, let's do contain inline size. And nothing changes there. We're also going to need to contain the layout. And there's going to be a few changes there. Once we contain the layout, we wrapped around our floated element. So it's sort of like a clear fix. It creates a new block formatting context. It clears all floats. It contains all margins. And it even contains fixed positioning. So you saw the fixed position element jump into the box. That's the main surprise you're going to run into. Is if you have fixed elements inside of containers, they're going to be fixed to the container. Style isn't going to have a big impact in most cases, although style containment does contain counters. But I think in order to show that, I would have to have a third counter outside again, and it would be 2 again, because the increased count on the figure in the contained box doesn't increase the count outside of the box, if that makes sense. So there's a few things that containment does to our boxes that make it so we want to be conscious and intentional about how we're applying that containment. But here's what we need. If we want to measure a box, we give it a container type of either size or usually inline size. And then we can take any media queries that are looking at things inside of that container. We just change the name from @media to @container, and now we're measuring the box that they're in. And we can also use the range syntax. The funny thing here was that I used the range syntax in all the examples in the spec. Browsers hadn't implemented it yet for the most part. But because we put it in all the examples, they were like, oh, we need this for container queries. So they implemented range syntax. It's available for container and media now. You can use like inline size or block size instead of width or height in those ranges. And you can do more interesting things with range queries. It's also recommended, but not required, that you name containers. And this allows you to say, I want to query a specific container that I'm inside of. If I'm in multiple containers, I want to query a specific one. We can give our containers a name. Names can be anything. They can be unique. They can be more like classes where you have multiple. I often do both. So I'll say, this main element, it's the main container, and it's also one of the layout containers. You can come up with any names you like and use those in whatever system makes sense to you. And there's a shorthand to do that. In the shorthand, names are required. So the shorthand is names first, and then the slash, and then the type of container. Yeah. Oh, right. So then you can say, I want to query this specific container. You can say @container and then the name of a container, and it will look to see if you are inside of that container and if that container meets the criteria. So for finding containers, each element on the page that's matched inside of a container query will look through its ancestors, and it will find the nearest ancestor that has the required name if given, and the required container types, and then it will perform the query on the nearest ancestor that meets the requirements. And this is maybe obvious, but I always think there's a little bit of something mind-bending about it. That means you can have the same element 2 places on the page, and it will have a different answer, right? I mean, that's the point. But also, sometimes it's a little weird, right? Yes, the same thing, the same code, 2 different places can get a different answer and look different. Containers can't self-query. That's part of the loop problem. Children always query ancestors. So containers can respond to queries, but they will always query the next container up. They can't query themselves. We're not just measuring ancestors, but actual elements. Oh, here's an example. Eric Portis made this to test whether he would break the browser by nesting lots and lots of container queries. So here are 36 chambers of container queries, each of them responding to the next container up. And you can see that they're responding just fine. So when we measure a container, we're measuring the content box of the element itself. We're always measuring an element, which changes some things from media queries. So one of the things that we get out of this is we're measuring actual styles. If we do a container query based on ems, which this one is, min width 20 ems, and then we have a media query that is also min width of 20 ems, the media query adds that border. It's looking at browser ems on the viewport, which is almost always 16 pixels. But the container query, which adds a teal background, is measuring the size of an em on our root element, which is the container, which has a font size of 2 ems. So it will be twice as big when it shifts. So we can now use em-based media or em-based container queries to do responsive sizing based on the actual font sizes of the container themselves. And that has some other implications, too, that we'll look at. The one problem here is that grid tracks and flex spaces aren't elements, and they don't match the size of the parent container element box, right? So in a grid context, we actually want to measure the track that we're in, not the containing element. So that's a little bit of a problem here. So I recommend doing what I call turtle elements. They carry their container with them. So here is a Flexbox example of that. Each of these elements, these are the same card elements, and each one is an article inside of a card. So there's a little bit of an extra wrapper there to make it work, but then the card acts as our container. We put container type inline slides on the card. It's in the flex space, and then the article responds to the container queries. And so we can see each element in the Flexbox is able to respond individually. And I'm not sure why those images are broken. But we get what we wanted there, measuring the flex space or the grid space by putting the container inside of the flex or grid track. This is a demo by Una Kravitz that does something very similar. She's also using the has selector, which is a fancy new selector, to change things depending on whether they have an image. But there you can see each one responding to the space that it's in a grid. And if we have web components, thanks, Zach. Web components are handy for this because they automatically carry their container with them. If we look at the, nope, not there. That's too small. If we look at the code here, the container queries are here in the scoped style inside of the web component. And then each book element has its content, author, title, and cover. And in the CSS, we're not doing as much there. But the nice thing is the host, where is it? Sorry. The host can act as the container. So the host is that custom element that's been created. There's always that extra host wrapper around web components. And so we can use that as containers, and then they can respond to any space. So we can drag things. Now I want to be zoomed out. Yeah, we can drag things into different spaces. And with the same code, they'll respond to the space that they're in. That's a demo by Max Bach. Here's a demo of a weather widget responding to both height and width by Martin van Hoof. Unicravitz has this example of using container queries in a nested context. So we say, not only is the button inside of a card and responds to a container, but you can see that the icon itself is also responding to its container. And the icon changes at different sizes. So we can have containers inside of containers inside of containers all the way down. And of course, Jay Tompkins. So for legacy reasons, there's no default container. The root element is not a default container. The viewport is not a default container. We have to supply our own containers. So if container queries don't find a container, they will fail. They won't respond. And I'm not going to go into the details here. There's a lot of implications with trying to add containment to the root, and we're trying to fix some of that. You can sort of get around it by doing a couple lines of code, but then you lose performance scrolling. That's not great. A little bit simpler solution is to say that the main areas of our page are all going to be containers. So here I'm saying any header, main, footer, or aside that's directly inside of the body, make it a container. And then we just make everything in our main layout a container, and then everything inside of that will respond to those containers. You can do that how you like, but there's no root container that you'll get by default. It's not great. We're working on it. I think there might be some solutions, but there's going to be some trade-offs to get what we want. We also get container query units. So if you've seen viewport units, viewport width, viewport height, viewport inline, viewport block, vmin, vmax, we now have CQ versions of all of those same units. So CQW, CQI, they give you the size of the container that they're in. And here's an example by Scott Kellum doing that. We can see we're getting different font sizes in the different boxes, even though he's using the same sort of Utopia FYI clamp that you saw in the last talk. He's using the same thing, but just changed the viewport units to container units, and then made each of these boxes a container. This one is by Val Head, and shows, that's interesting that it's so small, shows how to use these units for animation as well. So she's animating these clouds across. Well, she's using container queries also to change, let's see where it is. Let's make it bigger, if that goes. Yeah, so she's showing and hiding parts of the SVG based on the container query, but then also using viewport units to animate the clouds across the screen from the start of the container to the end of the container. So that looks like this. They're animating from a calculation of 0 container query units minus 100% the size of the cloud to 100 container query units. So to visualize that, 0 CQI minus 100% is just off one edge, and then 100 CQI is just off the other. And we can do sort of the inverse. We can go from 0, if we want to be always inside the container, go from 0 to 100 CQI minus 100%. So some other useful ways to put those to animation use cases. In this case, we do get a default, because we figured it's really risky if you're using units all over the place, and sometimes they are nothing. So you do get a default small viewport size returned if there's no container. The small viewport, if you don't know, is, so we had viewport units, but they changed depending on whether the Chrome of the browser was in or out, whether the keyboard was in and out, things like that. So the large viewport is with all the Chrome gone, how big is it? And the small viewport is with all the Chrome there. So we fall back to the small version for container query units. And when we were working on these, we thought, wait, so we can ask boxes anything about themselves. We probably want to know more than just the size. Oh my God, we have so many questions for these boxes. And they know the stuff. So we should be able to ask. So style queries are coming. There's a spec. Chrome has implemented it. Nobody else has yet, but there's positive feedback. So we can say, if my container has the colors custom property set to invert, do something else. And for this, there's no containment required, because there's no potential loops here. You always just query the direct ancestor unless you put a name, and then you can query a specific container name, but you don't need to set any container type or get any containment. All elements are style containers by default, and so they always query the direct parent. So here we go. You can kind of use this for mix-ins. So I have a container query that says, if the style is button theme Mia, then apply certain styles. And if it's Mia plus, apply better styles. You can tell they're better, because I'm a designer. You can also use this to do things like color scheme. Again, here I'm using has to check the selection. And I'm only setting, because with color schemes, you might want to set them based on the user agent styles or the user preferences. You might want to set them based on a toggle, and you might also want to set them specifically for certain elements on the page. You might have inverted elements. So you end up potentially repeating all of your themes 3 times to define them. And this lets us just change one thing. We're just changing what is the current scheme setting in the various places, and then we check what is the current scheme on our root, and we make our theme styles based on that. So it's a way of taking a lot of information and wrapping it up. With this one, we're looking at web components again and using style queries as a way to pass in custom parameters for styling our objects. So again, the host is a container, and it provides some default values for our parameters. But we can also pass in different parameters when we call the custom property or through our CSS. So the middle one there, we've flipped the theme to light, and we've flipped the grid so that the image is on the other side, and we've rounded the media. And then for the angry child at the bottom, I think they're passed in through HTML here. We set up a default. And just using style queries then to apply all of that. So we say when the style is flipped, or when the style is dark, or light, or fancy, which is what the frowning girl got. Very fancy. I'm a designer. Handy tip, generated content, like in this case, the arrow at the top there, generated content is inside of its box. So a generated element can query the element that it's generated on. So we've got bubble after has this little green arrow, and it can respond to container queries on bubble. So we can change arrow position start, and that will move. And I'm going to jump through a little faster. This is an example where you can change, like, turn on testing, and it puts outlines around everything. There's an interesting thing where, because we're looking at computed values, we can use custom properties in the queries, and they'll resolve on the container. So you get to compare two custom properties to each other and see whether they match. That has some implications, though. I recommend Manuel's article about that. Style queries aren't fully supported everywhere yet, but browsers have been giving positive signals. I think we will start to see them soon, although only for custom properties. It's too hard right now to implement for all properties, so you can only query custom properties for now, but maybe forever. We'll see. We're also working on state queries. This hasn't been fully spec'd yet, but the idea is we should be able to check, is something position sticky and currently stuck? Is it in an overflow snapped context and currently snapped? We should be able to apply special styles based on those sorts of states. And there's already a prototype of that in Chromium browsers. So you can see this is using the currently stuck. You can look at that later. It's still a little bit buggy. We'll work it out. So who knows? We think those will be coming soon. So the answer, do containers know stuff? Yes. They know quite a bit of stuff. Ask them whatever you can think of and see what you find out. They know their size. They know custom property values. They know relative values like ems. And maybe they'll know some state stuff too, which is pretty cool. So please do actually query the containers now. Actually, thanks.
Thank you so much, Miriam. There are questions,
Great.
So many questions. So that's wonderful. Thanks so much for bringing it all. I mean, for me, it's always so inspiring in some way to see, like, again, you know, asking this question: Can we please query the container? And the answer was no. And then, can we query the container? And the answer was no. And then, just what, like 1.5 years, 2 years passed, and then the answer is yes. So I think that many people are wondering, how does it work with CSS? Because for a long time it felt like a little bit sluggish. Like if you compare JavaScript's iterations and evolution, everything was happening so fast. And CSS often felt to many like, oh, like, you know, you would read comments and articles like, oh, okay, excellent that it exists, but let me wait for 5 more years until it lands in every browser. So what is different now that it has become possible?
Yeah, several things are different. One is that we have evergreen browsers. Most of the modern browsers are shipping every 6 weeks. Even Safari, though they won't tell you when it's coming, and they'll call it a minor release even though they're shipping container queries, they're still shipping regularly. So that's a big difference. But then also, performance of everything just keeps getting better. Mm-hmm. And the browsers have all recently, or mostly recently, updated their rendering engines. They've made big changes, and it actually slowed us down for a little bit. There were a few years there where it was hard for browsers to ship anything because they were rewriting their engines. But now that they've done that, it's making them able to ship faster and do more.
Right, so many things have become possible. That brings almost existential questions. One of them is coming from Sasha. So, do we even need media queries anymore? Shouldn't we just embrace an inside-out design philosophy from now on that makes media queries almost a bad practice?
For size queries, I think you might be right. For size queries, you might be able to move almost entirely to container queries. And the only reason to use a media query is if you really want that root container, and it's hard to apply a root container for container queries. But media queries are still useful for prefers color scheme, prefers reduced motion, device interface features like hovering. There's all sorts of other things that you can query about the media that will still be useful. It's just size and new things like style and state that will move to container queries. So I think you'll still need both, but for layout, you might be moving entirely to containers.
Another question, there was no author there. Would it make sense to have a component, I think, would it make sense for a component to be able to check a parent of another container in another position on the page, not its direct parent?
Yeah, so using names, you can jump up to other ancestors, but you can't jump over to cousins. You can't go outside of your tree. I'd have to think about exactly what that limitation is, but it seems like you would introduce even more loops if you could jump out of the tree and query something else.
Right.
Yeah.
Makes sense. Mika is wondering, what are some of the CSS bad habits that you see people doing despite newer and better ways of doing things?
Ooh, how long do we have?
6 minutes, 15 seconds.
I mean, I would say the main advice I would give is that CSS is designed for the browser to take a little bit of information from you and figure out a whole lot that you haven't thought of. You cannot think through all of the implications of your CSS. There's no way, it's too much. And so CSS is designed for you to say something simple and the browser to do something very complicated. And so the goal of writing good CSS is to capture as much information as you can in that one line. So you might say 16 pixels is the same as 1em, so it doesn't matter which unit I use. And in CSS, that's totally wrong. 1em is an entirely different thing from 16 pixels, even when they look the same. Even when they're the same size on the screen, they mean different things. And that's the importance of all CSS, is how much meaning can you give to the browser so that it can figure things out for you. So saying this size is relative to that size means something else, even if it's the same sizes. That's, I would say, the main thing that I see people doing that stresses me out, is thinking that things are the same because they have the same result on your screen. On other screens, they're going to have different results. They mean different things. CSS is all about conveying that meaning, not the final result. Because the final result, like I showed earlier, it's going to be different on different browsers, on different computers.
Right, right. Well, talking about one-liners, right, there is a very simple question. It's one word, probably just the shortest question throughout the entire conference. The question is subgrid, question mark.
Yeah, who is it that it's Chromium, right, that we're waiting on at this point? I think Safari and Mozilla shipped it years ago. Safari shipped it recently. Chromium was waiting on their engine rewrite. The engine rewrite is done. I've heard it's coming soon. I don't know dates, but it's definitely, I follow the bug, and there's regular updates, so I hope we'll see it soon.
Oh, that's, I mean, if I just think about it, actually, like, it's so incredible because I think for I don't know how many decades, because I jumped into CSS maybe 2004,
yeah.
5-ish. For so many decades, I was like thinking, I mean, I was, naive back then, like parent selector. Just please give me a parent selector. Now it's like, check,
yep.
Oh, we have way more than that, right? And then I was always like, I don't know if anybody felt like this. When I was just starting out writing CSS, I would do float left, okay, that works. Float right, okay, that works. Float top,
Yeah.
that's weird. Float why does float top doesn't work? And I would put important on it and everything. It still wouldn't work. It was so surprising to me.
What we
still
would
doesn't work,
need
does it?
is better fragmentation. I want to work on this. I think Rachel Andrew has been talking about float bottom as something you can do already in CSS in print. So there's a lot of CSS that's used by print companies that browsers have never implemented because it's only useful in print.
That's interesting.
And there's a lot that we could do there by having better fragmentation in the browser.
Yeah.
But the other thing to say with, sorry, say the question again.
Parent selector first. It wasn't a question, it was just
Well, I was thinking about it with the question that came before.
the question that came before.
I blanked.
Subgrid,
Subgrid, right. Containers and subgrid. Containers contain layout. Subgrid is a type of layout that needs to track outside. So you're going to have to be careful with subgrid and containers. Once we have both of them, a container will cut off the grid propagation between a subgrid and a parent grid. So watch out once you have both.
Oh, that's interesting. I think overall, when we think about this, I think one question that often comes up is, what would be the good way to organize CSS at this point? So for a while, like 2015, we were talking about IT CSS, BAM. Anybody uses BAM? Yes, I think it has changed a little bit with the notion of, well, we can just scope our things in our React components, things like that, right? CSS and JS and so on. So where do you see it's heading now? Like, what would be a best practice, so to say, to organize CSS
well, I have
when you
another
start
talk
writing?
on that.
Oh, that's
if you have another hour.
We have 1.5 minutes for now.
You can come to my workshop tomorrow.
Which is a good idea, by the way.
I would say a lot of the systems out there, like ITCSS or OOCSS, a lot of them are based on the Cascade. They're taking ideas that the Cascade already gives us, and they're sort of codifying them. And more we're also taking some of those ideas and putting them back in the Cascade. So inverted triangle CSS, Harry Roberts' thing, he would define lots of layers. And we said, that's a great idea. And we added Cascade layers. And so now I would say, using basically his approach, but put them inside of Cascade layers, and it's explicit, is a great way to organize CSS. The idea is to go from general to specific. So we start with broad styles that we want applied everywhere, fonts and colors, and then we get more and more detailed about specific components as we get farther in the code.
Mm-hmm. So maybe the final one. So Miriam, if you think about the kind of your wish list, things that you would love to see in the browsers, CSS related, of course, tomorrow. If you could wake up one day and say, you can do anything, it will just land tomorrow, what would it be? Or what would you like to work on next, like the big goal in front of you?
Yeah, it's a good question. I think there's a lot that we can do if we improve fragmentation. Fragmentation is like when you print, fragmenting from one page to the next. But what if we could do that in the browser? We should be able to do something like regions, where we fragment from one grid area into another grid area. We say flow, and if you overflow this area, flow into that. And I think there's a lot we can do there that needs to be explored. I'm also looking at mix-ins and functions from Sass. Do we want mix-ins and functions? What would we use them for? How might they work if we put them in the browser?
Okay. Well, I do have to ask that one because it's another short question. The competition for the shortest question keeps going. The question is masonry ?
Masonry, yeah, it's the next level after subgrid. So you would think once subgrid ships, maybe masonry will ship? ?
Okay, that sounds like a great answer. And then there is just a final note. Miriam has the best shoes ever.
Thank you, I made them.
That's not a question. That's not a question, it's a statement.
Okay, great.
All right, excellent. Thank you so much for being with us, Miriam.
Thank you.
Thank you.